Hi, and welcome to our WebRTC Fiddle of the Month. With me is Philipp Henke, and we're going to talk about Poor Man Simulcast today. It started from FaceTime Web being announced, and Philipp going and checking what they've exactly done there, and finding some interesting things, right?
Yes, they choose a non-standard approach to Simulcast, and I looked at it for WebRTC hacks, so you can read the full post there. But I think the techniques they use is interesting enough that we can take a look and talk about it.
Okay. And I think before we start there, it would make sense to explain what Simulcast is exactly. So let's pick that.
Yes, Simulcast is one of the most important topics in multi-party WebRTC.
Mm-hmm. So Simulcast adds us flexibility. We've got a media server, the SFU, selective forwarding unit. And what it needs to do is to forward the media that it receives from each one of the participants in the session to the other participants. Since you want the SFU to be lazy and not use CPU to encode or decode actual media, what we do is use Simulcast. And in Simulcast, the actual devices are the ones that are doing this encoding. Instead of sending a single stream towards the SFU, they can send even 2 or 3 separate streams, multiple media streams towards the media server. And each one is going to be at a different bitrate, which means different quality, different level of quality, resolutions, frame rate, or just pure quality. Now, the SFU receives these 3 inputs, and then it makes a decision which one to send to which of the participants. So in this case, it decided to pick the 1.5 megabit per second, the highest quality stream. At some point in the future, towards the exact same device, it can decide to send a lower bitrate. It can also send different users different bitrates, and it can change that dynamically over time.
Yes, one example is, for example, when you're displayed in a different size. So in a thumbnail, the SFU wouldn't need to send me the full 1.5 megabits per second. That would be wasting a lot of bandwidth.
It's like now that we're side by side versus seeing us at the top when there is something that is being displayed. And at the top part, we actually edit and put it down to the side in picture.
Yes.
Okay. And you've got a fiddle or demo or code to show us.
Because the important thing here is to remember that the browser can send simulcast, but it cannot receive simulcast.
Mm-hmm.
And FaceTime took a different approach here. So let's look at that. So what we have here is based on the Simulcast Playground, which is a JavaScript-only way to visualize simulcast, how it works in the browser. And typically that has one peer connection sending simulcast, so sending 3 tracks, and on the other hand, splitting it up. Because the browser cannot receive simulcast, it can only send it. Mm-hmm. And we do some SDP magic to visualize that. Okay. And what we do here is we look at how FaceTime does it, because FaceTime sends and receives 3 different streams. And it seems like it does some kind of switching between the videos in the client application.
Okay, so instead of the SFU making that selection and sending, the SFU is still making that selection and sending, but the client, instead of not knowing what happens, needs to understand that there are 3 separate streams and that the SFU sends data or media only on one of them at a time.
Yes.
Okay.
And we're going to look at 2 different ways to really switch between those videos. The first one is to reattach the source object property, which is a media stream. Mm-hmm. And I hope we can see that one. So I'm trying to demonstrate that. And we have the small resolution stream now. Mm-hmm. And we're switching to the mid resolution and to the high resolution. And sometimes you can see a lot of visual flickering here, but it doesn't happen right now.
Okay.
Sadly. So it was.
I guess one of the I guess that one of the main problems here would be timing. Because if I'm the SFU and I'm now sending 3 different streams. I'm actually sending one at a time. But the client needs to know which one is being sent and then switch between them, either because I sent him signaling or because he sees packets coming on one and not the other. But that is done on the application level, which is a bit too high. So it
Yes.
might be later in the process, whereas here you always have all 3 video streams available, and you switch between existing video streams that actually have data on them at all times.
Yes, and that wasn't even possible in WebRTC in the past, or at least not in a reliable way. But FaceTime uses the insertable streams API to do this kind of detection which media stream is the active one. So we're going to look at that a bit later.
Okay.
So the second approach to the switching is to have 3 different video elements and then hide 2 of them and just displaying one of them.
Okay, so when you click the switching, it actually changes which video element is being displayed and the other one gets hidden.
Yes, and that is flickering a lot less because then it's just like CSS, and the browsers are incredibly good at CSS. So let's switch. So we can see there's almost no flickering. But if we have a very continuous motion, you can sometimes see that things jump backwards slightly because the different streams have different timestamps, so the synchronization is a bit off.
And you probably won't see it in this video because this video is something that we do inside the WebRTC call that then gets recorded, then gets edited, then gets into YouTube or Vimeo, and you're going to play it back from there.
Yes.
So the easiest way would be to go to the URL below this video and to play it on your own.
Yes. Make sure to look for things like blurring or this switchbacks, these small jumps in the video.
Okay. And you wanted to show something in the code?
Yes, that was interesting. So insertable streams is a API that is mainly used for end-to-end encryption. But what I saw in the FaceTime JavaScript was similar to the code I've written here. So we have something that works on the decoding end of the connection. That gets called for each encoded frame. And we have a mapping between we record the last RTP timestamp we've seen for a specific SSRC. And if we don't have a timestamp, we initialize it and say, okay, there's a current RTP timestamp minus 100,000. And then what we do is we look for keyframes. And if we get a keyframe and the timestamp is recent, then we switch to that one. Because then we know, okay, we are prepared to switch, and if we have a keyframe, we can decode the video and we can switch. And here we have the 2 variants. One that is reattaching the source object, and that's causing this flickering, and it's very annoying. And the second one is to say, okay, we're showing only one video and hide the other ones.
Okay.
Yes. And then we just note the last timestamp of the frame we have.
Okay. So if you stop sharing, you can go and look at the differences themselves. So let's see why, whenever someone does such a thing, it's interesting to understand why. So we did prepare this small table. And in normal simulcast, we have the sender, the receiver, and the SFU. The sender, in our case, has a single media stream track that it created, and it generates 3 different SSRCs, one for each of the 3 video bitrates that it is sending out, the 3 layers in a way. The receiver, on the other end, doesn't know what simulcast is, so it has a single media stream track and a single SSRC throughout the whole session. It doesn't matter if the sender or the SFU, the media server, is going to switch from one track from one bitrate to another, there is going to be a single SSRC for the receiver. In order to do that, the SFU or media server will need to take the 3 inputs that it has, decide what to send to the receiver, but then send it only over one SSRC, which means that it will need to rewrite the SSRC that it sees from the sender. Because it is doing that, it will also need to rewrite the timestamps and the picture IDs.
Yes.
So that's like work that is being done by the SFU in order to support Simulcast.
Yes, and it's a pretty complicated thing, actually, in particular if you have things like packet loss, rewriting the timestamp and the sequence numbers gets a bit tricky.
Okay. And then we've got the poor man's approach to Simulcast, which is what Apple decided to do for FaceTime. And there, what they're doing is the sender has 3 media stream tracks instead of 1 in 3 different SSRCs. So it's actually sending 3 separate, distinct video sources. On the receiver end, we've got, again, 3 media stream tracks and 3 SSRCs. The receiver knows that it is Simulcast and it is aware of what is happening. All this is done on the application level. Because of that, the SFU doesn't need to do any rewrites, it just needs to pass the media directly from the sender towards the receiver. Okay,
Yes.
so the estimate is that this was done because the FaceTime team didn't want to do all the rewrite stuff on the SFU. They deemed it unnecessary or too much work.
Yes. Also, this approach plays a bit nicer with end-to-end encryption, which is probably a big topic for them.
Yes.
And this is not the first time I actually see this approach. We did that very early in the life of the Jitsi video bridge, but it didn't work so well. So I'm surprised to see it again. But it was interesting to look at.
Okay, but I'd say that at least our suggestions to developers is to use a normal simulcast approach.
Yes.
Because that's tried and true. Everyone uses that, including Google, which means that this will work best on their browser.
Yes.
Okay. So thank you for joining us for this Fiddle of the Month, and see you next month. Bye.
Bye.